Hi guys, my name is Dr. Pankaj Jeswani, and in this short video I'll be discussing the Bielschowsky three-step test. Right? This is a bit of a complicated topic, so I'll try to make it as simple as possible. Right? Firstly, what is the Bielschowsky three-step test? So it is a test used in vertical diplopia. It is a test used to isolate or identify the paretic muscle in a case of vertical diplopia, right? In vertical diplopia, you have 8 possible muscles that can be the culprits, or that can be the paralytic muscle, right? So why 8? Because the medial and the lateral rectus, they have no role in the vertical movement of the eye, right? Medial and lateral rectus only move the eye sideways. So the remaining 2 recti and 2 obliques, so superior rectus, inferior rectus, superior oblique, inferior oblique of the right eye and the left eye. So in all 8 muscles can be possibly affected in a vertical diplopia. Okay? So Bielschowsky test is basically a sequential 3-step test which will narrow down these muscles. So after the first step, out of those 8 muscles, only 4 muscles will remain. After the second step, those 4 muscles, only 2 muscles will remain, and after the third step, you will get the actual muscle that is paralytic in a case of vertical diplopia. So how do we go about identifying that paralytic muscle is the question. A typical question on this topic that is asked in the exams is they'll give you a history of vertical diplopia. Then they will say that on examination there is either right hypertropia or left hypertropia, and the hypertropia or the diplopia increases either on right gaze or left gaze, or alternatively they can say increases on right head turn or left head turn. So that's the second step, and then they will say that the hypertropia or the diplopia increases on right head tilt or left head tilt. So those 3 steps, and you'll be able to identify the correct muscle. Before we begin with the Bielschowsky test, it is useful to remember, to help us understand, we need to know some baseline rules. We need to understand some of the extraocular muscle movements, right? So I've written down the 3 important rules that you need to remember. You don't actually need these rules for the PARC test, but to understand how we arrive at the PARC test, these rules will help you. Okay. So the first is, which extraocular muscles are the entorters of the eye? So I remember this using the mnemonic SOSRI, also called sorcery. I call it sorcery or something like that, right? You can use your own mnemonic, but basically remember that the superior oblique and the superior rectus are the entorters of the eye. The second point to remember is that the recti are adductors and the obliques are abductors, correct? Although remember that the maximum vertical action of the recti occurs in the abducted eye. When the eye is in abduction, that is when the maximum vertical action of the recti occurs. On the other hand, the obliques are abductors, but their maximum vertical action occurs in abduction. Knowledge of these 3 rules will help you to understand how we arrive at the PARC test. I'll be describing the application of these rules as we go about. Now, to solve the PARC test, you need 3 pieces of information that will be provided in the question. The first is, which eye is hypertrophic, right? Hypertropia, it could be either right hypertropia or left hypertropia. The second, the hypertropia is worse in which case, either right gaze or left gaze. Alternatively, they can say whether the hypertropia is worse in which head turn, right? You have to remember that if the hypertropia is worse in right gaze, it will also mean that the hypertropia is worse in the left head turn, right? Right gaze, left head turn, they are kind of synonymous. Okay. Also remember that the third point is hypertropia is worse in which head tilt. Okay. With these three pieces of information, you can proceed to the next most important step of the park test. Once you have this information, these 3 points, the next step is to drawing the edge diagram, right? So edge diagram is a basic diagram in which you note down the direction of the action of the muscles, right? So you've got here the right eye, here you have the left eye, this would be the right gaze, this would be the left gaze, right? So you have to remember that the recti, these are adductors, but their maximum vertical action occurs in abduction. So this direction is abduction. So here you will have the right superior rectus, here you will have the right inferior rectus, here you will have the right superior oblique and the right inferior oblique. Okay. Similarly, the left eye you can draw, it's basically parallel, but this is the most important step, because if you get this step wrong, everything else is pointless. You will make a mistake, right? So remember these things, right? Okay. So here you can see that I've drawn the edge diagram, and once you have the edge diagram ready, then you can start processing the information that we had previously collected and start identifying the affected muscles, right? After you've drawn the edge diagram, the first step is we collected the first piece of information, whether it's a right hypertropia or left hypertropia. So we highlight the affected muscles based on that information. If a right hypertropia exists, that means that the depressors of the right eye are affected, or the elevators of the left eye are affected. Affected meaning paralytic. Okay? So we'll highlight those muscles. So in this case, for right hypertropia, it's going to be right inferior rectus or right superior oblique, or in the case of left eye, left inferior oblique or left superior rectus. Go ahead and think for yourself. If it's a left hypertropia, what elevators and what depressors are affected, and you'll be able to highlight the correct muscle groups. Now the next step is to take into account that the hypertropia or the diplopia is worse in which case, correct? So let's take the example of the right gaze. So when the eye is in the right gaze, for the right eye it is abduction. Now recti are the muscles whose vertical action is maximum in abduction. So if for the right eye, the right gaze is causing an increased hypertropia, that means that the recti are involved. So which is why you can see the highlighted images in that photo are right superior rectus and right inferior rectus, correct? And for the left eye, left inferior oblique or left superior oblique are highlighted. Why? Because in the right gaze, the left eye is in the adducted position. If this is very confusing for you, just remember that if the right gaze is worse, you have to highlight the muscles that are on the right side of the edge diagram, correct? So you can see that this and this is the right side of the diagram, and this is on the left side of the diagram. So if right gaze is worse, highlight the muscles on the right side. Left gaze is worse, highlight the muscles on the left side. Now the third, now this is an important step. The third piece of information, whether the diplopia or the hypertropia is worse in right tilt or left tilt. Okay. First you need to understand what happens when there is a head tilt. Whether what is the basic movement occurring in a head tilt. Let's say this is a normal head, it turns to the right side, okay? So there's a right head tilt here. In a right head tilt, because the head is tilting this way, the right eye is going to intort and the left eye is going to extort, okay? So this head tilt is going to cause intorsion on the same side an extorsion on the opposite side. Okay, right? Now, if right tilt is making the diplopia worse, that means right tilt is making the diplopia worse, which means that the intorters of the right eye are poor or the extorters of the left eye are poor. Okay, which is what has been highlighted in the diagram here. What are the intorters of the right eye? Right superior rectus, right superior oblique. SOSRI, sorcery. These are intorters. So those two are highlighted. Or in the left eye, you have the extorters, which are paralytic, which are underacting, which is why on the right tilt it is getting affected. I hope so far it's been clear. Even if it's not perfectly clear, we'll take a few examples, and with the examples you'll be able to understand a lot better. Okay, so let's say that in the question you've been provided three pieces of information: right hypertropia, worse in right gaze, worse in right tilt. Okay, I'm taking a simple example for us to be able to understand properly. So if it is a right hypertropia, you have to remember that the depressors of the right eye or the elevators of the left eye, these are the ones that are affected. Okay, so far so good. Now, it is worse in right gaze. So we said that if it's right, then you just have to highlight the piece, the pair that is on the right side of the edge diagram. So we've got these two, correct? The third one is worse in right tilt. Okay, so worse in right tilt means that right eye intorters are poor or left eye extorters are poor. So, correct, superior rectus and superior oblique are the intorters, they are poor, and inferior oblique and inferior rectus are extorters. In the left eye, they are poor. At the end of this edge diagram, you will get two shapes. You will get a triangle like you've got in the right eye, or you will get something like this, which is not a triangle, right? Wherever you get this non-triangle is your affected eye, and wherever this thing, wherever the 3 points meet is your affected muscle. That is the rule of the Parkes test. That is a simple way to work out the Parkes test. Okay. Now you can, or a simple way to understand this is that any muscle that is being highlighted 3 times is the affected muscle, right? Here you can see that the superior rectus highlighted twice, inferior rectus highlighted twice, superior oblique highlighted twice, left superior oblique highlighted once, left superior rectus highlighted once, left inferior rectus highlighted once, left inferior oblique is highlighted thrice. So that is your affected muscle. Right hypertropia, worse in right gaze, worse in right tilt. Parkes test gives you or isolates that the left inferior oblique is affected for you. Okay, that's your answer in the question. We'll just confirm this again. Right hypertropia, right gaze, right tilt. You can see this, that the left inferior oblique is the affected muscle. Let's take another example. In this case, there is left hypertropia, which is worse in right gaze, and it is worse in left tilt. Okay, so you practice this on your own. You can pause this video and practice it on your own, and resume the video, and the answer is going to be left superior oblique. Okay, just try it for yourself. You'll be able to answer 3 or 4 questions. You practice 3-4 questions, you'll be able to answer them really well. Just remember that to cross check, one of the diagrams has to look like this, and the other diagrams is going to look like this. One will be a 3-sided a triangle, the other one will not be a triangle. I don't know what that shape is. It's just an angle, XY axis. I don't know. Hope you understood that part 3-step test, and I hope you will be able to answer that question correctly. based on application of the rules or the principles that we discussed. However, it's often the case that you don't have a lot of time in the exams. So this is a cheat code that, if you just remember the shapes and where to label the muscles, you will be able to answer this question even without having to apply yourself, even without having to think a lot in the exam. Okay, so you can pause this, you can take a look at this. In right hypertropia, you're going to have these two muscles, right? If it's worse in right case, you're going to highlight the muscle group on the right side of the H diagram. If it's a head tilt, that's going to be the shape. On the other hand, if it's a left head tilt, you have these two muscle groups affected. If it's a left case, highlight the muscles on the left side of the diagram. And if it's a left tilt, you have to choose these two muscles. Basically, it's this kind of, remember this V diagram, okay? It will help you with your, it was simple, and I hope you'll be able to answer this question. Let me know in the comments below.